In early 2025, the barrier to software creation practically vanished. Using natural language prompts, anyone with an idea could describe a vision and watch as their smartphone screen morphs into a polished, professional application interface. Tools like Cursor, Replit, and Lovable drove a productivity explosion, enabling teams to build prototypes 10 times faster than traditional programming. What once took weeks of manual engineering was now being compressed into hours. But this velocity came with a hidden cost. Cybersecurity researchers found that nearly 70% of AI-generated code ships with critical vulnerabilities that are immediately ready for exploitation. The consequences were material. A startup called Moltbook inadvertently exposed 1.5 million API keys within days of launch, while the T-app leaked private user messages because of a single overlooked security logic error. These breaches aren't caused by broken code. In every case, the software compiled perfectly and performed exactly as the user requested. There were no syntax errors or logic crashes to warn the developer that something was wrong. This creates a dangerous paradox. AI rarely writes broken software. It writes software that functions flawlessly while quietly leaving the front door wide open. Large language models function as statistical prediction engines. When they generate code, they are optimizing for the most plausible continuation of text based on patterns in their training data, rather than reasoning through a software architecture. This lack of reasoning leads to semantic omission, vulnerabilities created by what is absent from the code, rather than what is written on the screen. This diagram shows the difference in intent. On the left, a human engineer understands the threat of unauthorized access and intercepts users with a security shield, like row-level security. On the right, the AI provides the most direct path possible, creating a line from the user straight to the database. The AI omits this security layer because it lacks any contextual awareness of external threats. Unless the prompt explicitly demands it, data packets will bypass every necessary authorization check. Models also fall into a training data trap. When asked to secure a system, they frequently suggest MD5 encryption or other outdated patterns, simply because those insecure methods statistically dominate the historical data the model was trained on. Because the model prioritizes syntax over security, it acts as a high-speed autocomplete tool. It can perfectly mimic the shape of a building without grasping the physics required to keep it standing. If these AI-generated apps are full of structural holes, why don't our standard cybersecurity scanners catch them before they reach the public? Most traditional scanners use static application security testing, or SAST. This laser passes line by line over the code, turning red only when it detects a signature, a specific known pattern of bad text. But a scanner cannot scan what was never written. When the laser passes over the empty gap where an authorization check should be, it sees nothing bad. It issues a passing grade to a structural void. Deploying vibe-coded apps protected only by traditional scanners creates a fatal illusion of safety. You're essentially guarding against typos while the entire perimeter remains unsecured. By 2026, venture capital firms began requiring vibe coding audits before seed or Series A funding rounds. They are searching for what they call structural time bombs, latent vulnerabilities that can destroy a startup's valuation as soon as the code is exposed to real-world traffic. Detecting these time bombs requires behavioral testing. Instead of just reading the text, this method executes the app and actively attempts to bypass its safeguards, forcing the code to prove its security at runtime. This has established a new workflow: vibe and verify. AI models generate the repetitive boilerplate code, while human experts focus exclusively on rigorous architectural verification. This hybrid approach is increasingly common among open-source pioneers like Linus Torvalds. High-stakes foundational components are meticulously hand-coded and reviewed, while AI is relegated to assisting with peripheral tools and utilities. Software engineers have transitioned into the role of strategic gatekeepers. Their work has shifted away from the manual typing of syntax and toward the high-level modeling of threats. In this post-syntax environment, generating code is a cheap commodity. Human judgment and structural verification are now the only true defenses against systemic catastrophe.